3.3 concavity and the second derivative test. A second derivative is give you the information about the concavity. When it's concave up, the second derivative of your function is positive. If your function concave down, second derivative is negative. Look at this. This graph from here to here, your graph is concave up, so second derivative is positive. From here to here is concave down, second derivative here is negative. And again, it's concave up here. Second derivative is going to be positive. There are points that concavity change. This point is inflection point, and here is as well. Second derivative at inflection point is 0. So the second derivative, as we said, inflection point is 0, right? For the local maximum or local minimum, the first derivative is 0. And if you wanted to, the first derivative is 0, means that point is your maximum or your minimum. How do you know this is maximum or minimum? One way is to check the second derivative at that point. Let's say your first derivative at point A is equal to 0. So x equal to A is your maximum or minimum. You take a second derivative and you find the sign of second derivative at point A. If it is positive, means it's concave up and you have a local minimum. If the second derivative at point A is negative, it's concave down and you have maximum. This is how we check you have maximum or minimum. Find the points of inflection and interval of concavity. So inflection point means second derivative is equal to 0. You take first derivative, so power in front 4x power 3. Power in front 6 multiplied by 2 is 12, x power 1, and you have a negative. The root of constant is 0. So this is my first derivative. Second derivative, you take another derivative from first derivative. Power in front 3 multiplied by 4 is 12. Power minus 1, 3 become 2. And negative 12 for x is a line, so the slope of the line is negative 12. This is the second derivative. You factor 12 out. X power 2 minus 1 is a difference of the perfect squares, so it's going to be x minus 1, x plus 1 is the factor, equal each bracket to 0. From the first one, x minus 1 equal to 0 means x equal to 1. X plus 1 equal to 0 means x is negative 1. Then you need to do the number lines. See, here is I'm going to do the number line. So here, negative 1 is a smaller one and 1 is the biggest one. You put a line below that. And at negative 1, your second derivative is 0, and once your second derivative is 0. These are point of the inflection. I need to do the test point. Between negative 1 and 1, you can choose any number like 0. Above 1, choose any number 2. Below negative 1, choose any number like negative 2. These are the test point. If you put 0 here, this bracket 0 minus 1 is negative, 0 plus 1 is positive. Positive multiplied by negative is negative. Sorry, negative is here. And if you put negative 2 minus 1 is negative 3, negative 2 plus 1 is negative 1, negative multiplied by negative is positive. You put 2 here, 2 minus 1 is positive, 2 plus 1 is positive number, positive, positive, positive. So here is concave up. In this is concave down because this is negative. And then here is concave up. So you see this is a concavity. Second derivative show you the concavity again. Now, so yeah, that's it. Now the worksheet, the questions you do, question number 1, question number 2, question 3B, 4B, and question number 5.